Hello, we are on section 7.6 and 7.8. We're going to be translating and solving word problems and then also learn some scientific notation. So we have some signal words that can help us to translate whenever we're going to need to write out a phrase or in the future, later in the lesson, equations. And so some of them are fairly standard and you recognize them, you're going to know what they mean. For instance, weight divided by 14. So you get to choose your variable. And so weight divided by 14 might be W divided by 14, or you could write W divided by 14 in fraction form, because remember that fraction bar also means divide. 6 inches more than the length. Now when you're writing this, you don't need to put the inches in our phrase, but what you do need to do is just put the 6 in, and of course we know the inches were there in the first place. So 6 more than the length. More than is going to tell us that we are adding. So I'm going to use L for length, and then we add 6. 1/2 of the original torque. So 1/2 of, that is a clue that we might multiply. It also means that we could divide if we're splitting it in half. So 2 ways to write this. We could say 1/2 times the torque, and we don't have to put a times sign there because when we write 1/2 next to t, that means multiply. We can also write it as t divided by 2. All right, so either one of those would be fine, and once again, like I said, you get to pick your variables. I'm just trying to pick some that maybe make sense in the problem. Now on this one, it says the sum of 2 widths. So they're both going to be a width, but we have to distinguish those in some way. So you could name them different variables, or one of the ways that I like to do this is take width sub 1. So that subscript identifies that it's going to be a different number than the width sub 2. So using the subscript is just to help distinguish between the two W's in this case. All right, so we're going to translate more phrases into math expressions. On the first one, it says the voltage decreased by 5. Decreased means subtract, so we're going to take the voltage and subtract 5. And then on the next one, 8 inches less than twice the height. So this one got a little more complicated. Less than means I'm going to subtract. Twice the height means 2 times the height. So we're going to take 2 times the height and subtract 8. Now this would be good to be pausing here and trying these on your own before you see what I have to write. Number 7, 4 times the gear reduction. And so we can call this whatever we want to as far as variables, but it says 4 times the gear reduction, so we're multiplying by 4. So we can write 4 times g. You can use a different variable. You can write it this way, but remember it's not really necessary. It's perfectly fine that way because we wrote the 4 right next to the g, which means multiply. And then the last one is the product of the width and length. So product means multiply. So we're going to multiply width times length. So you can write W times L, or you can just write it side by side, WL. I guess I should make this one look a little more like it's capital letter like I did on the first one. Okay, so that was some fairly simple translations into phrases, and now we're going to look at some formulas, equations. It says translate into algebraic formulas. Now on these we didn't have anything where it said is indicating that it's equal to something because they were phrases. These are actually going to have an equal sign because it says is. For instance, the first one says the sum of 2 weights is 167. Okay, so I already showed you the sum of two weights, right? We're going to use a W with a subscript of 1 and then a subscript of 2 because that's indicating that we have two different weights. Is a clue word or a key, a signal word for equals, and then it equals 167. Now all we're doing on these is writing them. We don't have to do anything else with them. Okay, the next one, number 10, general trades. The weight in kilograms is equal to 454 thousandths times the weight in pounds. So we have to kind of, maybe name these. So the weight in kilograms, let's call this K, and let's call the weight in pounds P. All right. So the weight in kilograms is equal to 0.454 times the weight in pounds. So weight in kilograms is equal to 0.454 times the weight in pounds, and so we're just going to say times P. And when we write it right next to the P, that means multiply. Okay, the next one. The volume of a cone is 1/3 times pi times the height times the square of the radius of the base. So that was a lot of stuff, wasn't it? So the volume, I'm going to call that V, of a cone is 1/3 times pi times the height times the square of the radius of the base. Now, times the square of the radius means radius squared. And so this whole thing was multiplication. It was telling us times this, times this, times that. And then you just have to get it all in there. All right. Next. The pitch diameter D of a spur gear is equal to the number of teeth on the gear divided by the pitch. Okay, so the pitch diameter D is equal to, right? So D is equal to the number of teeth on the gear divided by the pitch. Now we can decide what we want to call this. You could call the number of teeth T, we could call it N, divided by the pitch, and we could call that P. All right, so let's do the number of gear teeth. So we'll say the number of teeth on the gear divided by the pitch, so N divided by P. Now remember, on my lab, on some of the things that we've been doing, you had to be careful with whether you did uppercase or lowercase. On these, you get to decide which way you want to go with that. All right, the voltage, number 13, the voltage across a simple circuit is equal to the product of the resistance of the circuit and the current flowing in the circuit. All right, the voltage, all right, so we've got the voltage, which we'll just call that V, across a simple circuit is equal to the product of the resistance, and product, remember, that means multiply, resistance of the current and the current flowing in the circuit. All right, so a common thing to call the current is I. Now we can put that in as a capital I if you want to, but it's just the product of these two things. So, I meant to make that an R, not a P. So the voltage is the current times the resistance, or the resistance times the current. Normally we're going to put the smaller letter before, or the alphabetical letter before the R, so I comes before R. We write it that way. It's okay if you would rather write it this way, write IR. Perfectly fine. If you write it RI, that's also fine, because remember, multiplication can be done either way. The order doesn't matter. Okay, so this is all leading to translating into equations from a word problem where it's not so straightforward as the ones we've been looking at. So here is just some information about how to do this, right? So we're going to read the problem carefully, noting what information is given and what is unknown. Underline the keywords and or cross out other words, and so that's always helpful, and maybe some highlighting even. Assign a variable to represent the unknown. If there is more than one unknown, try to represent them using the same variable. So you don't want to put more than one variable in an equation that you have to solve, because you wouldn't be able to solve it, right? That only works if it's a system of equations. Write an equation using the unknowns, solve the equation, answer the original question. Sometimes after you solve, you still have to go another step to actually answer the question, and then check your solution. So this is just something to help guide you through this. One thing that you have to do is just read carefully and kind of work your way through the problems. All right. So when we're setting this up, it's how we do this is going to be rather important. Okay, so machine trades. 2 metal castings weigh a total of 84 pounds. So right there it tells us weighs a total. It sounds like we might be doing some adding. One weighs 12 pounds more than the other. How much does each one weigh? Okay, so we have a total of 84 pounds. One weighs 12 pounds more than the other, right? So 12 pounds more than the other. And then it says how much does each one weigh. So what I like to do when I'm trying to set up one of these is I just identify my variable. So I'm going to say X is equal to the first casting. So I'm going to name one of them, and that way I can base the other one on this. Right, one of them weighs 12 pounds more than the other. All right, so this X is going to be the other casting, the first casting. And then that casting plus 12 will be the second casting. Whoops, I'm going to put the D in there. So now I've named both of them, and my total weight is 84 pounds. And so once I've done this part, putting it into the equation is not so bad. So I'm going to say X plus 12 equals 84, right? So here's my first casting, there's my second one, and together those equal 84 pounds. To solve, I'm going to combine the x's, so 2x plus 12 equals 84. To solve, I subtract 12 on both sides, and that gives me 72. We divide by 2 on both sides, and x is 36, and that happens to be pounds. So remember, the first casting was my x, and the second one is going to be x plus 12, right? So x plus 12 would be 36 plus 12, which is 48 pounds. So you can go back to that and just say, okay, I'm going to put in 36 plus 12, and that gives me the 48. It said, how much does each one weigh? That's what we were trying to find. And so these are answers right here, right? One was 36 pounds, and the other one was 48 pounds. All right, so I'm going to stop the video and start up the rest of the lesson on the next one, or it may take 2 more, I don't know. So see you on the next video.